Section 4.2 Application of Quadratic Function. As we know, if you have quadratic function, then you might see quadratic function look like this: ax squared plus bx plus c, where a, b, and c are some real number. They are some real number, and a cannot be equal to 0. And based on the value of a, if a is positive, then you have concave upward graph, and if a is negative, then you have concave downward graph. And if you have a positive, you are going to get the minimum value of that function. If a is negative, then you are going to get the maximum value of that function. So basically, whenever we need to try to find out the maximum or minimum value, whenever we try to optimize some function, then this quadratic model is very useful. Meaning, we try to model the problem using the quadratic function. And since we can find out this minimum or maximum value of quadratic function by using vertex formula, by using the vertex, then we are going to, we will be able to solve the problem. So in this section, or any section in this course, if you are looking for maximum or minimum value of the function, or maximum or minimum value of anything, then try to model the problem using quadratic function. Okay, and find out the vertex. So this is the formula for vertex. Negative b over 2a is the point, x equal negative b over 2a, and then y equal the value of the function at negative b over 2a. So that's how you find the vertex. Let's look at one example. A toy rocket is launched with an initial velocity of 44.1 meters per second from a 1 meter tall platform. The height h of the object at any time t seconds after launch is given by the function h of t equal negative 4.9 t squared plus 44.1 t plus 1. Question: how long after launch did it take the rocket to reach its maximum height? And another question is, what is the maximum height obtained by the toy rocket? So think about this. You have a toy rocket and it's launched from 1 meter height. So there is a toy rocket and it's launched from 1 meter height. So this is the path, which is the height of the rocket from the ground. Let's say this is the ground and this is the height of the rocket, and that can be modeled by this height can be modeled by using this quadratic function. Okay, and we would like to find out when, at what time the rocket will be at maximum height. So as you can see here, this height function is quadratic function. A is less than 0, that means it should give you this kind of shape. And then if you find the vertex of this quadratic function, then you would be able to answer this question. So the first question is, how long after launch did it take the rocket to reach its maximum height? So that means it's the x coordinate of the vertex. And then what is the maximum height? That's the y coordinate of the vertex. So this is the height function, and we can use the formula for finding the vertex, which is negative b over 2a, for the time. That is actually h and k I was talking about. That's the vertex. And if you remember the formula is h equal to negative b over 2a, but in our case it's a time, that's why t equal negative b over 2a. And then height is height function, h function at that time. So by using this formula, if you plug the value of a and b, you can see a is negative 4.9, b equal 44.1, and c equal 1. So I put b equal negative 4.9, and negative negative times negative is positive, over 2 times a. As you can see here, b is 44.1 and a is negative 4.9. Okay, I was mistaken here. So b is 44.1 and then a is negative 4.9, and by plugging this value and using your calculator, you will be able to find out it's a 4.5 seconds. And height function at that time is, just plug t equal 4.5 second here. That will give you 100.225 meters. Okay, so the rocket will be at maximum height, which is 100.225 meter when the time is 4.5 seconds. Next question. Sometime you might have to solve business problem, maximizing function in economics. For that you have to know one at least one formula like revenue. Dollar amount received by selling X items at a price of P dollars per item is, this is the revenue formula. Revenue can be calculated by multiplying the number of item, this is number of item, and then price of that item. As the quantity X increases, the price P tends to decrease. Always it happens, that's called price demand function. When the number of item increases, price decreases. When the price increases, number of item decreases. As the quantity X decreases, the price P tends to increase. So finally there is another formula that's called profit equal revenue minus cost. So this is basic information you have to know before you solve problem from from this area. Let's take a look one example. It's supposed to be example 2, not the 3. uh, so here you have given, just read this information here. Records can be kept on the price of shoes and the number of pairs sold in order to gather enough data to reasonably model shopping trends for a particular type of shoe. Demand functions of this type are often linear and can be developed using knowledge of the slope and an equation of lines. Suppose that the marketing and research department of a shoe company determined that the price of a certain type of basketball shoe obeys this demand equation. So this is just a background, so to change to model a real life problem using quadratic function or any function, you have to have some kind of data, and that is what they are saying here. By using a lot of data, some data, research department model this demand equation. You don't have to understand a lot about this. This is just a background information. This is the relation between the price and the number of item. So now the question is, according to the demand equation, how much should the shoes sell for if 500 pair of shoes are sold? So meaning, what is the how much should the shoes sell for? Meaning, what is the price? How much should the shoes sell for if the 500 pairs of shoes are sold? Meaning, what is the price if a number of shoes pure sold is 500? So that's the first question. Second question is, how many what is the price if the number of shoes pure sold is 1200? So we're going to find that information by plugging x equal to 500 first and x equal to 1200 here. So if you put x equal to 500 here, that would be 100 bucks. If x equal to 1200 here, that would be 86 bucks. So the price of the shoes would be 100 bucks if you sell 500 shoes, and then price would be 86 bucks if you sell 1200 shoes. So here, if you put that information on the x-axis, which is the pair of shoes, which is x, and then this is the price, these are the 2 points we are going to get. And by using these 2 points, we can find out this equation. That's what we have given already. Now the second question is, make sure that this is example 2. The second question is, what is the revenue if 500 pairs of shoes are sold? You need to find out the revenue. We know that revenue means it's a number of shoes times price. So we're just going to put x equal 500, and then the price is 100 bucks. X equal 1200, and then price is 86 bucks. We already found that. So now revenue equal x times p. So revenue is equal to negative 100 over 50 x squared plus 110x. So we are going to find out the revenue by plugging x equal to 500 and x equal to 1200. So when x equal 500, the revenue would be 50,000. When x equal to 1200, the revenue would be 103,000. And we can find out this information by plugging x equal to 500 here and 1200 here. So if you plot the graph of this revenue function, this is what you are going to get. Because the revenue is quadratic function, we can also find out the maximum value of that revenue by finding the vertex. And that is our last question. The question is, how many pairs of shoes should be sold in order to maximize the revenue? So look at here, we want to find out the maximum value of this quadratic function. So that means we are looking for the vertex. So vertex means we know the formula for the vertex is negative b over 2a. So in our revenue function, if you go back here for the revenue function, it's a revenue function is negative 1 over 50 x squared plus 110x. So b is 110, a is negative 1 over 50, and c is 0. So by using that fact, we can find out the x coordinate of the vertex, which is 2750 pairs. And then y coordinate of the vertex can be found by plugging that 2750 in the revenue function. That is $151,205. So the revenue would be maximum when we sell 2750 pairs of shoes, and then revenue is 151,250. Okay. So now the another question is, what price should be charged in order to maximize the revenue? The price is, because maximum revenue can be found by when x is 2750, the price of the shoes should be can be found by using this formula. Just plug x equal to 2750 in this formula, and then it will give you the price of shoes should be $55. So we are going to get maximum revenue if we sell 2750 pair of shoes with the price $50, $55 each pair. So so always I just did two examples here, but keep in mind whatever problem you have to do in this section, quadratic function, try to connect that with the vertex formula, because that vertex formula is going to give you the maximum or minimum value of that quadratic function.